Okay, so welcome back friends. Welcome back in another video tutorial from microbiology with Shagnik. So today's topic is all about transmission electron microscopy. So in our previous video we have discussed about the sample preparation of the electron microscopy, and before that we have also discussed about the principle of normal electron microscopy in a separate video. So now today we will discuss about transmission electron microscopy. So let me told you that transmission electron microscopy is based on the normal electron microscopy. Okay, so it was developed by Albert Prevost and James Hillier at the University of Toronto, and they have used the concept provided by Max Knoll and Ernest Ruska. Okay, so the concept that was developed by Max Knoll and Ernest Ruska was what I have explained in the principle of electron microscopy lecture, where I have told you that why electron is used for providing better resolution, because you know what, why we have developed another group of microscopies known as electron microscopy, just for getting a good resolution. That is the idea, right? So we have, if you have watched the very first video of microscopy, then I think you know that the resolution is inversely proportional to the wavelength, right? That means if you are wanting to get a good resolution, so the light source that you are using should have a shorter wavelength. Okay, so that is the concept that was developed by Max Knoll and Ernest Ruska, because they thought that if they use electron instead of light, because you know what, light is nothing but electromagnetic radiation, right? So instead of light, if we use electron, electron can also create the image on the image plane. Okay, so that is the idea, and this idea was adopted by Albert Prevost and James Hillier, right? And that is why the name transmission electron microscopy. As its name suggests, transmission, that means the electrons are transmitted through the specimen, and these transmitted electrons are creating a image of the object, right? So this is the ray diagram of transmission electron microscopy. Okay, so the first important thing is there should be a electron source, right? That can be cathode, which are emitting high voltage electron beam. Okay, so again another important thing I want to again explain you, that here the condenser not specimen, objective lens and the projection lens, that all kind of lens that we are using for the magnification purpose are not glass. Okay, they all are electromagnets. Okay, that is the very important thing you have to remember. Okay, so now from the electron source, electrons are focused onto the specimen. Okay, and from the specimen a portion of the electron is transmitted. Okay, the portion of the electron that is transmitted contains information about the detailed structure of the object that we have considered as a specimen. Okay, so now this transmitted light will be further magnified by objective lens and projection lens, and then it will hit the fluorescent screen. There can be also CCD, which is our charge coupled device camera, or also magnetic plate. Okay, these three kind of image plane that we are using. Okay, so after hitting, they will create a image of the object. Okay, and this image that what CCD or fluorescent screen or magnetic plane has detected will be recorded by a computer program. Okay, in real time. That's how we can get the image of the object, right? So idea is very simple, that we are using electrons. Okay, these electrons are of shorter wavelength. That means if this electron have the ability to create the image of the specimen That means make sure it very clearly that the image that the electron will create will be having more resolution than what we have get in our earlier times when we have used the light microscopies. Okay, so another important point that here all the lenses are magnetic lenses. Okay, and the image plane that we are using are fluorescent screen or CCD or photographic plate. Okay, so the electron will be hit in the fluorescent screen, okay, and they will create a image that will be recorded in the computer program. Okay, so that is the idea of the transmission electron microscopy, exactly same of the original electron microscopy or the electron microscopy concept that was developed by Ruska and Max Knoll. Okay, that means Albert Previs and James Hillier just practically constructed the electron microscopy. Okay, the actual concept was of our Max Knoll and Ernest Ruska. Okay, that is, you have to remember that transmission electron microscopy principle is nothing different from what we have discussed earlier, that is the normal principle of electron microscopy. Okay, it is exactly relied on this technique. Okay, but now there is a problem that we have faced, because you know what, this electron microscopy is very highly costly. Okay, that means the price of those electron microscopy is very high. Okay, so now you just think that you are buying a car, this car will give you a good mileage. Okay, but this car is not good looking. Okay, this car is like kind of old fashioned. So what is the utility? You surely think about this, that what is the utility, how I can spend too much amount of money in this cars, right? Similarly, scientists also try to think about this, that why we are constructing electron microscopy just only for magnification and resolution. We are spending crores of money, right? Because yes, there is no doubt that transmission electron microscopy will provide you a 1 million times magnification. Yes, obviously you will get a detailed and resolved image product, but the image is still 2D. Okay, so that is the reason why after the transmission electron microscopy development, scientists developed the same, that is scanning electron microscopy. That is will be our topics in the next class. Okay, so TEM obviously provides a lot of advantages. So the TEM offers the most powerful magnification, potentially 1 million times or more. TEM have wide range of application in educational field, in industrial field, in scientific field, and TEM provide information on elements and compound structure. Images are highly qualified and detailed, and they are also easy to operate with proper training, and TEM are able to yield information about the surface structure, shape and size. Okay, so that is the advantages part. And in disadvantages, another important disadvantage is that images are still black and white. Okay, and they cannot give you 3D image, they are creating 2D image. Okay, and TEM are very large and expensive. A proper housing and maintenance is necessary for TEM. Also the operation and analysis required proper training and potential artifact from the sample preparation, and this is obvious because you know in sample preparation we have discussed sample preparation that consists of near about 5 to 6 steps, right? So without proper training and proper manual practice, it is nearly impossible that you will create or you will prepare your sample without any artifacts. That means the chance of artifacts is obvious. Okay, so that is the advantages and disadvantages of the transmission electron microscopy. Now for better understanding, I will share a GF sorry, not GIF, it is GIF. So this GIF will help you to understand about transmission electron microscopy, and I have taken this GIF from internet, and I will also provide the link of this GIF. Okay, so this is one. So it consists in an electron emission source, electromagnetic rim. So this is the electron emission source we will discuss in our next GIF. So an electron detector and electromagnetic lens, right? And now let's move this one. So let's see what is happening. So as you can see, light is coming, that is here, not light, electron is coming from the cathode, okay, and this electron are of high voltage, okay, and it is magnified and it is focused by the condensers that we have using. And remember again about that the condensers are magnetic here, and after condenser it will pass to the specimen, and then specimen it will be hitting in the fluorescent screen and creating image in the computer, right? So that is the idea of the transmission electron microscopy, that here our light source, that is of electron source here, and this electron source is white hot tungsten filament in some cases that will provide a high voltage electron. This high voltage electron will be focused onto the specimen by condenser lens. Again, this is a magnetic lens, not made up of glass. Now from the specimen a portion of the electromagnetic light will be transmitted, and after transmission those transmitted light will be magnified and it will be creating a image in the CCD or the fluorescent screen or the photography plate, and this image is then transferred to the computer and we are getting the image of the sample in real time. Okay, so that is the concept of the transmission electron microscopy. So I hope now it is very clear to you, right? That transmission electron microscopy is nothing new. It is exactly the electron microscopy principle that we have discussed, and it was developed by Albert Prevost and James Hilliary in the University of Toronto in 1938, and they are using the same principle of Albert Ruska and Max Knoll. Okay, here they are using a electron source. From those electron source they are creating a image by using CCD or photographic plate. Okay, and advantages are it provides you a very high magnification, near about 1 million time magnification. The images are detailed and resolved, okay, and also it provides the detailed structure, detailed shape and detailed surface structure, right? And it also tell you information about the compound and elements structure, okay. But disadvantages are, as you can see in this GIF again, that the images are still black and white, okay. And another important disadvantage, it is too much costly and large. A proper housing maintenance is required for this process, and in turn it only gives you a 2D image, okay. So in next video we will again come with another microscopy that will going to solve the disadvantage of the TEM, that is the same. This same will solve the disadvantage, that this same will help you to create the 3D image, okay. So till then friends, bye bye, take care.